Okay, welcome back. And here's our last section in Chapter 1. And these again are some more word problems dealing with distance, rate, and time. And these, as you'll see, are very, very important to handle in a box. And we want to remember that the big formula here is distance is equal to rate times time. And that is what will guide our work in all of these problems. So here's an interesting problem. Read this a couple times. Make sure you get the idea. Make sure you understand what the question is. Now, we're going to use a chart to set this up. And all of these charts are going to look the same. And the way they'll look is with distance equals rate times time. Now we're going from Boston to New York. So this is to New York, and then going from New York to Boston. And we don't know what the distance is, but we know that the rate going to New York is 90, and going to Boston is 120. And so therefore, let's see here. This is similar to the previous problem. We know the total flying time is 7 hours. So if we say that going to New York is t hours, then how much is it going to Boston? If the total time is 7, then this must be 7 minus t, and that's the big deal. So therefore we know now that distance is rate times time. So this is 90t, and this is 120 times 7 minus t. And now we have to think about where we get an equation from. And if you think about these two distances, well, they've got to be the same. One is going from New York to Boston, the other is going to Boston to New York, but the distances are the same. So therefore, 90t is equal to 120 times 7 minus t. Now, if you solve this equation, and you should, go ahead, press pause and solve it and see what you get. And you should wind up with t equals 4 hours. Well, that's interesting, but that's not the question. The question is, what's the distance between the cities? Well, this distance and this distance are exactly the same. And so to find the distance, it's easy to plug into this equation, this expression. And so 90 times 4 is equal to 360. And so I answer the question and say the distance is 360 miles. And there we go. So that's a pretty good problem, and that's one to study again before we move on to the next. So read this one carefully and try to make sure that you understand the important facts and the important data. So I've set up this table, and now we have to fill in the information that we know. So let's see here. We know what the rates are for each of them. That's pretty direct. So the jet is at 570, and the propeller plane is at 190. Now we have to interpret this important information that the propeller plane has been flying 2 hours longer than the jet plane. So if the jet plane is traveling for t hours, then that means that the propeller plane is flying for t plus 2 hours, right? 2 hours more. That expresses that relationship. So now the distance that we get is 570t and 190 times t plus 2. And what has to be true about those two distances? right? Those are the distances in which the jet has overtaken the propeller plane, which means the two distances have to be the same. So let's write that down. So this expresses that the two distances are the same. And so if I work on that a little bit, I'll get 570t is equal to 190t plus 2 times 190, which is 380. Now we solve that, and we get t is equal to, 1. So when does the jet plane, how far? Well, we can use either this or this, and neither one, we get the answer of 570 miles. So jet catches prop after 570 miles. Okay, always answer in a sentence. Okay, let's try one more. So read this one. Sure is a lot of information. Got a student walking part of the trip, jogging part of the trip. We know how far he goes, and we know how long the trip takes. And the question is, what portion of the trip does the student jog? So we set up our chart as always. So here we go. We got the walking part and the jogging part. We know the rates at which they walk and jog. But now I've got to figure out what should go in the times. And so, again, we've seen this a few times now. The total trip takes an hour. So we have two pieces that make up an hour. So again, if I call this t, then how much is this going to be if the total is 1? That's the big part. So press pause and think about it if you need to. And if they add up to 1, this has got to be 1 minus t. T plus 1 minus t gives me 1. And that's how long the total is. Well, now this is 5t. And this is 9 times 1 minus t. And where's my equation going to come from? Well, remember, the total distance is 8 kilometers. So this piece of the distance, the walking piece, and the jogging piece, have to add up to 8. So there's my equation. 5t plus 9 times 1 minus t has to equal 8. 5t plus 9 minus 9t is equal to 8. So what does t equal? So press pause, solve that equation, and tell me what you get. And if you do it carefully, you get t is equal to 1/4 of an hour. So how far did the student jog? Well, the student jogged this much, which is going to be 9 times 1 minus 1/4, which is 9 times 3/4, which is 27/4 kilometers. And so we write down the student jogged 27/4 kilometers. And that's good enough right like that. And that ends chapter 1. See you soon.